Alright, so here we have the LT Spice app. Here is the diagram of our circuit with the potentiometer. The potentiometer has three terminals, 1, 2, and 3. The terminal 2 is also known as the signal arm. This signal arm is connected to a metallic wiper here, which is in contact with our resistance material here. So let's assume this is 6,000 ohms of resistance material. So the wiper can be moved clockwise or counterclockwise using the knob. That resistance material here is similar to this one. So it is a series connection of 6 1000 ohm resistors. So this is the resistance material of our circuit, of our potentiometer. This is the wiper, which can be adjusted up or down. Up means clockwise, down means counterclockwise. This is our terminal 2, terminal 3, terminal 1. Okay, so now let's use this app. Okay, here. So the wiper is positioned here, then the voltage is 9 volts. So across the circuit we have 9 volts and the current in the circuit is 8.3 amps. The circuit that I am referring to is this LED and resistor in series. Okay, looking at this circuit, we have a parallel circuit of our resistance material here, which is the 6,000 ohms, and the external circuit with 1,000 ohm resistance. So, parallel circuit. Now, according to a law known as the Kirchhoff's current law, this current here in the main line will be divided into two parts. One will flow to our resistance material and another will flow to our external circuit. So let's denote this as I1, this is I2, and this is I3. According to the Kirchhoff's current law, if we are going to add all of these three, it will become 0. So the summation of current is equal to 0. In other words, this I1 is equal to the sum of I2 and I3. Now, according to Ohm's law, the lower the resistance, the higher is the current. Okay. Comparing the resistance here, 6,000 ohms and 1,000 ohms, we have a lower current of I2 compared to I3. So that's according to Ohm's law. So most of the current will flow to our external circuit because it has higher or lower resistance. Because of its lower resistance, we have a higher current here compared to I2 flowing in our resistance material. Another way of looking at this, still using the Ohm's law, these 2 points, terminal 1 and terminal 3, we have the highest resistance that we can have. According to Ohm's law, V is equal to I times R. So if we have a higher resistance, we also have a higher voltage. So across these 2 points, we have 9 volts, the maximum voltage. Okay, so that's according to the Ohm's law. So we can use two laws, the Kirchhoff's and the Ohm's law. Now let's adjust the wiper up to the middle. So here is our wiper now. So our wiper here in the circuit is connected or positioned at the middle. So checking the voltage, we have 2.19 volts. And the current is 1.5 volts. Okay, so there is a huge decrease in the current and the voltage. So from bright to dim. Okay, so we now have a dimmer brightness of our LED simply because of a lower voltage, and lower voltage means lower current in our external circuit. So what happened here? So looking at our circuit now, we have made a series parallel circuit. So in our main line, we have added resistance, and that is 3,000 ohms of resistance in the main line. Across these 2 points, we have also 3,000 ohms of resistance. According to Ohm's law, if we have decreased the resistance, we have decreased the voltage. So there is a drop in voltage across these 2 points because we have chosen a lower resistance. Take note, in our Ohm's law also, I is equal to V over R. Now this equation, the R here is not the R in this one. Okay, the R here is this 3,000 ohms here, which is in series with our parallel circuit here. So increasing the resistance here means lowering the current in the main line. So we have decreased the current here. The resistance here across terminal 2 and 3 has decreased, so meaning the voltage, the output voltage across these 2 points has also decreased. Because of this decrease in resistance, there is a decrease in voltage, and the decrease in voltage led to the decrease in current in our external circuit. That is why the LED here has become dimmer. Okay, now so let's adjust our wiper to here at terminal 1. Looking at our meter, we have 0 amp. So at this point, the LED becomes dimmer up to a point that it's no longer lighting up. So the LED is not lighting up anymore. So what happened here? Now looking at our circuit, this terminal 2 and terminal 1 are touching each other. So the wiper has allowed the terminal 2 to touch terminal 1 already. So across these 2 points, the voltage is now equal to 0. Why 0? There is no more resistance here. Okay? So the resistance is almost equal to 0. Again, according to Ohm's law, V is equal to I times R. Any number multiplied by 0 is equal to 0. So we have 0 voltage here. And 0 voltage means 0 current. So the current in our external circuit is also 0. So our LED is no longer lighting up.